Okay, 2.6 continued, basic functions. Number 5, the cube root function, taking the cubed root of something. What I want you to notice is it does look pretty similar to the cube function, except for it's kind of like it's turned sideways, okay? Just to kind of see what's happening, I'll make a little table here. I don't think it's hard to see if we take 0, we have cubed root of 0 is 0, hence the 0, 0 here. If I were to take something like -1, we can do the cubed root of -1, and that's -1. -1, -1. Same thing with 1. Next, if I take an 8, I want the cubed root of 8. That's going to be 2. 8, 2. Okay, so this is a little different. Instead of shooting up real fast, it's going kind of like this. Kind of like that whole square root situation, except for it's a cubed root. And finally, -8. Cubed root -8 is going to be -2, so I have -8, -2. Okay. So notice here, I don't have to actually restrict the domain, and actually, I won't have a restriction on the range either with this cubed root. And that happens with any odd roots, because we can take odd roots of negatives, and we can get both positive and negative values. So for my domain and range, it's all real numbers for both of these. Okay. The next one we want to be familiar with is called the absolute value function. F of x equals the absolute value of x. Okay. Now you may be familiar with, oh, I just turn it positive then. Well, kind of, but it's actually defined as the distance from 0, right? So if I make a quick table, not hard to see that we're getting what's on the graph here. If I want the absolute value of -2, that's also going to be 2. That's why we have this thing that kind of looks like a V. Okay. So if we ask the domain, ask ourselves what the domain is, what are all the x's? It looks like it'll be everything. Think about if there's any restriction. Can I take the absolute value of any real number I put in there? I can. So the domain here is -infinity to infinity. However, we do have a restriction on the range. Okay. First of all, I don't see a graph down here. Second of all, these are our outputs, our answers, our y coordinates. If we take the absolute value of something, can we ever get a negative answer for that? The answer is no. Okay, so this one, we could get 0. We have to start at 0. We're throwing all this out and going to infinity. So that's your absolute value function. The last one I'll mention, okay, I'm not going to spend a lot of time on this, is called the greatest integer function. This is actually used in business a fair amount of times, and as you can see, there's a lot of discontinuities here, okay? So it's written like this: f of x equals this x with 2 little boxes around it. What it does is it pairs every real number x with the greatest integer less than or equal to x. So for example, if I have this 2.4 in those 2 boxes, the answer to that is 2. If I have 3.9, the answer is 3. It's kind of like, just instead of rounding, we're just truncating to the next lowest integer. So this is what the graph ends up looking like here. So 0, 0, it's kind of like a slide across. 1, 1, slides, 2, 2, slides. Because even if I had 2.99, that's still going to evaluate as 2. And the same thing happens this way. Sometimes, since this resembles sort of like a set of steps, sometimes we call this a step function. That's another thing you can call it. Okay? So be aware that that is a thing, right? And if you think about the domain, I can put any x value in. If I choose any x, I can get some y value. So the domain is all real numbers. The range, however, if we think about it, since it's the greatest integer function, the range is only integers. So how would we say that? I would say it like this: y such that y is an integer. Or I suppose you could start listing out -3, -2, -1, 0, 1, 2, 3, ... like that. So I just wanted to make you aware of this one. All right, so now that we have all the basic functions, I do want to mention piecewise functions. Okay, Piecewise functions, it's kind of just what it sounds like. They're functions that are pieces of other functions. So the first one I'll start with looks like this. F of x equals 6 minus x, and that's if x is less than or equal to 3, and 3 if x is greater than 3. Now, for this one, what I like to do is I want to find a few parts on each piece. I got 2 pieces here. So I see that the pieces change at 3. So I'm going to start, I don't know, let's go ahead, let's start with x equal to 0, because that's easy. If x is 0, then I'm using this piece since x is less than or equal to 3. So I'll have 6 minus 0 is 6. So at 0, 1, 2, 3, 4, 5, 6, I got the point 0, 6. Now, if you're clever, you can look at that and say, oh, yeah, that's linear with a slope of -1. But if not, you can always just plug in more points. So let's say 2. I'm still on the first piece. 6 minus 2 is 4. So I have the point 2, 4. I'm also noticing this thing is going down with a slope of 1. Now, here's the thing. If I use 3, ask yourself, which one should I use? Well, the one that's less than or equal to 3. What I'm going to do here with 3 is I'm going to put a closed dot next to it. And you may not know exactly why I'm doing that right now, but just bear with me, okay? So then we get 6 minus 3, we get 3, so we know the point 3, 3 is on here, and that's fine, so I'll even label it. Now, I'm going to do 3 again, but I'm going to use the wrong one, okay? So why would I do that? Well, the reason is I want to know if we're coming from the right-hand side, what value are we getting closer and closer to? And whatever point that is, we use an open circle, okay? So if I do that, well, it's just 3, that's fine. So under normal circumstances, if this was somewhere else, I'd just put an open circle and continue on. Since it overlaps with the closed circle, I just, fill in the circle and I just continue from there. If x is 4, it's 3. If it's 5, it's 3. So I can see kind of what's happening here. This is just constant afterwards, okay? And it goes up like this. And you can see this is, I can kind of tell this looks like a piecewise function. There's kind of 2 pieces here. Usually you don't get it to just stop at a corner like that, unless you have absolute value, but absolute value itself is actually also a piecewise function, okay? So that's one type of situation. Here's another piecewise function. I guess before I do that, we should fill out this domain and range. So the domain, if we scan this thing from left to right, I can see that that looks like it's -infinity to infinity. How about the range? I don't have any negative y values, and I never will. The smallest y ever is actually is 3. So I'm going to start at 3, and then it does go up forever in this direction. So I'm going to go to infinity. So you do want to know how to find those domain and ranges, even on the piecewise functions. Let's look at B. There's 3 pieces here. So let's start with the first one, -2x. If x is less than -3, I'll go ahead, I'll start at -5. That means I'm going to use this piece here. -2 times -5, that's going to be 10. So I got -5, 10. So let's see, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, way up here somewhere, right? -5, 10. Let's see what we get for the next piece, okay? So or for the next part, -4. -2 times -4 is 8. Okay, I see it has a slope of -2. So now I'm at -4, and I'm at 8. -4, 8. Okay, and just like I did before now, for -3, I should use this one, right? Because it's -3 is less than or equal to x. But I'm going to use -3 first, and I'm going to do an open circle to see as we come from left to right, what value are we approaching? It's very important to do this. So open circle, -2 times -3 is 6. Okay, so -3 and 6, and I'm going to use an open circle. Okay, and I'm actually not even going to put that on there because if someone asks you, hey, what's the function value when x is -3? The answer is not 6. It's going to be whatever we get when we plug into here, but we just want to know what it's approaching, at least for this graph. So now let's do -3 again, but let's use the proper one and use our closed dot, okay? That's that middle one, 3x minus 1, so 3 times -3 minus 1 is -10. So -310. So that's right here and way down here. -310. Notice I'm using a closed dot in this case. Notice this is still a function. It does still pass the vertical line test since this is open and this is closed. Now, 3x minus 1 has a slope of 3. So I can kind of see what's probably going to happen, but I'll pick another point. Let's pick 0. I'm still in that range. That's going to be 3 times 0 minus 1 is -1. So when x is 0, we have y equals -1. 0, -1. And now I'm going to do the same thing for 2. And it's less than or equal to 2, so that's the proper one, but I'll use the closed down. Okay? So I can see this is going up, 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 up pretty fast. And at 2, it's 3 times 2 minus 1 is 5. So 2, 5. So I'm up here, and it is a closed dot. So I can put that on my graph. That's going to be the 0.25. So notice so far, this thing is still a function. We just had these discontinuities, right? We call these jump discontinuities and continue on. After that, I'll use 2 again, but use an open circle and use the improper one just to see what we're approaching as we come from the right. Okay? So what's that going to be? That's going to be -4. Okay? And that's going to be times 2 is -8. So 2, -8. Open circle. After that, I see there's a slope of -4, so I just know this thing's going down. It's going down fast. Okay? I guess I should label a point on it. If I have 3, that's -4 times 3 is -12. So somewhere in here, if I just label that 3, -12. So look at that piecewise function. Okay. One other one to take a look at would be this one, not that one. I mean, that's not a bad one to look at, is C, where everything isn't linear. Maybe give that one a try. I guess one other thing I should do too is do the domain and range on this. The domain is really any x value, right? If I look over here, I can choose any x. Here I can choose any x, and then I can get any x over here. Notice also there's no restrictions on what x can be for plugging in. So all real numbers. Now we got to be careful on the range with this, because let's scan from bottom to top. We go, 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 go. Now we get here to y equals -8, but notice we do have it covered here, right? So I don't have to disclude that, -infinity, all the way up to, and then I get up to 2, 5, but then as I'm looking this way, it jumps from 5 to 8. So I have to take that off. So it goes -infinity to 5, including, notice that, I'm going, going, going. Oh, now I'm going to have to jump up like this. Oh, I'm sorry. Actually, that's not 8. That's from that open circle. That's 6, right? And then I have to jump to 6, but not include, and go to infinity. Okay. Sorry, I think I was off screen for that part. Okay. All right, and that wraps up 2.6.